The experiment will perform in which a spoon is plated with copper. The spoon will be cathode and the copper electrode will be anode. The spoon is connected to the negative terminal of a battery and is placed in an electrolyte bath containing copper ion. The positive terminal of the battery is connected to a copper electrode which is placed in the electrolyte solution. The copper sheet slowly oxidizes, making copper ion attracted to the spoon, regaining their lost electrode and becoming copper metal again, but now in the form of thin coating on the spoon. At the cathode, reduction process will happen, and at anode, oxidation process happen. Faraday's law of electrolysis relates the amount of material produced or consumed in an electrolytic cell to the quantity of electricity passes through the cell. The expected mass of a substance deposited during electrolysis can be calculated using Faraday's law that is shown in the slide.
An electrolyte solution of copper nitrate was prepared by dissolving 30.2 gram of copper nitrate solid in 200 ml of distilled water in a beaker. The solution was stirred until it was completely dissolved, creating a 0.5 molar solution of copper nitrate. The spoon was cleaned prior to electroplating. It was prepared by polishing with some sandpaper, washed in distilled water, rinse and dry it. And then its mass was recorded as shown in the table 1. The beaker was filled with the copper nitrate solution and the spoon was placed into the beaker. The apparatus was set up as shown in the video, ensuring that the strip and the spoon did not touch each other. The spoon was connected to the negative end of the power supply and the strip was connected to the positive end. The power supply was turned on and the stopwatch was started simultaneously. This experiment was run for 5 minutes with a current of 2.3 ampere. As you can see in the video, there are bubbles in the solution, which in the preparation of the copper-plated spoon, positive Cu2 plus ions from the electrolyte bath will become attracted to a key carrying a negative charge. When the Cu2 plus ions reach the spoon, they will gain electrons and become reduced, which is cathode, to form solid copper on its surface. The copper 2 ions removed from the bath must be replenished. This is accomplished at the anode where a solid copper strip undergoes oxidation, which is anode. After 5 minutes, the wires were disconnected and the spoon was taken out of the solution. It was rinsed with acetone and air-dried for a few minutes. And then the spoon was then reweighed. The experiment was repeated for 5 minutes, 10 minutes, 20 minutes and 30 minutes intervals.
Based on the data obtained in this table, the mass of the deposited copper is increased when the time taken for the electrolysis increased. We also measured the actual mass of the deposited copper, where we compare the mass obtained in the experiment to the expected mass to determine the accuracy of our experiment. In our case, the percentage error for time interval 1 and 20 minutes turned out to be over 50%, indicating a large difference between the expected mass and actual mass, which might cause from the experimental errors. However, the other percentage errors are still acceptable. In conclusion, Faraday's law concept states that the amount of substance deposited at an electrode is proportional to the quantity of electricity passed through the electrolyte. Faraday's law of electrolysis also provides a reliable method to calculate the mass of a substance deposited during electrolysis by relating it to the electric charge passed through the cell. In this discussion part, the results of the experiment showed a direct correlation between the duration of electroplating and the thickness of the metal coating. The graph of mass of copper deposited against the time was plotted. From here, the experimental mass is much lower than the expected mass. This indicates potential error or inefficiency in our electrolysis process. However, we still get the results same as the hypothesis of the experiment. As the plating time increased, the thickness of the copper layer on the cathode increased linearly. This was expected as a longer plating time allows for more metal ion to be reduced at the cathode, resulting in a thicker coating. In an electroplating cell, if the same metal is used in both cells, the rate of the electroplating process is constant. In conclusion, time is a critical factor in the electroplating process, affecting both the thickness and adhesion of the metal coating. While increasing plating time can lead to thicker coatings, there is an optimal duration that maximizes adhesion strength. That's all from us. Thank you.